Conserving germplasm is commonly achieved through seed banking. But not all seeds are created equal. Orthodox seeds are like they describe, predictable. They can tolerate drying and then freezing, which means they can be stored for decades or even longer. These orthodox seeds make up roughly 90% of global species, but there are always exceptions. These are the non-orthodox seeds.
So non-orthodox seeds are seeds that don't respond to the standard seed banking conditions that we use. It's no good putting a seed into those conditions if it's not suited to that. And there are some species that we can't dry and we can't freeze, and we don't want to destroy those seeds by treating them inappropriately.
Globally, it is estimated around 10% of plant species are non-orthodox. But this can be much higher in regions like the tropics or the subtropics. Traditionally, identifying and storing non-orthodox species has been tricky, but techniques have advanced a lot in the last 12 years. Of course, before we tell you the how, we have one other curveball. Unsurprisingly, there is more than one way to be non-orthodox.
So there's two main categories. So seeds that cannot be dried at all would be termed recalcitrant species. And so a lot of rainforest species, large seeds, they generally germinate fairly quickly, they survive in a moist environment. We can't dry those at all. They don't like to lose any moisture out of the seeds. Then there's a category of seeds that we can dry, or we can partially dry, but we can't freeze them, and they're classified as intermediate category.
Short-lived orthodox seeds such as orchids and some alpine seeds might need alternative storage methods to extend their lifespan. Now you know the definitions, but how do you go about identifying which seeds are orthodox and which are non-orthodox? The Germplasm Guidelines have a decision matrix to step you through the process.
Okay, so our first step, if we want to have a look at seed storage behaviour using the storage behaviour key, is to look up what's known about the species on the Q Seed Information Database. So you can just find this by going to Google and typing in QSID, and then you'll get this screen coming up. And if you type in the genus of the species that you're interested in, click on search, and that will bring up any information that's available. So in this case, we've typed in Castanosperma mistral, which is black bean, and you can see there that somebody's already done the work for us and found out that it's recalcitrant. So if there's no data available on your particular genus, or if the behaviour in the genus is inconsistent, then what you can do is use some seed characteristics to give an indication of how the seed's likely to respond to storage. So the first thing you can do is just cut the seed open. If it's quite hard to cut, if it's got one of those really hard impermeable seed coats, then we do what's called an imbibition test and just see if that seed is capable of taking up moisture without scarifying the seed. And if it can't take up moisture without that scarification process, then that's a really good indication that your seed is orthodox and it's going to tolerate both drying and cold storage. And if it's nice and easy to cut, then your next step is to have a look at the dry weight of the seed and the seed moisture content. And to do that, you just put a few samples of seed into an oven, weigh it before you put it into the oven, and then weigh it again after it's been in the oven at 103 degrees Celsius for 17 hours. From that, we can calculate the dry weight of the seed and the seed moisture content. If the seed is less than 20 milligrams in dry weight per seed, then that's going to be a desiccation tolerant seed. And if the moisture content is less than 20%, then that's also likely to be desiccation tolerant. And on the other token, if your moisture content is more than 50%, then your seed's really likely to be desiccation sensitive. So if you go through that process and you're still not sure how your seed's going to respond, the next thing you can do is look at a seed coat ratio. Okay, so what we're going to do now is have a look at the seed coat ratio, and that involves separating out your embryo from the seed coat. And if you have big seeds, make sure you chop them up so that they'll dry more easily. Then all we do is weigh a tray. Record the weight and give that container a code so that you know which one it is later. And take the tray out, and the first tray takes the embryo, and then we weigh a tray for the seed coat. Then these go into the oven at 103 degrees for 17 hours. Okay, so now the seeds have been in the oven for 17 hours and we're going to take them out and just need to cool them down before we re-weigh them. Otherwise, because they're hot, they'll just soak up the moisture from the atmosphere. We've cooled them down over silica gel so that make sure they don't absorb any moisture from the atmosphere. And now we're just going to re-weigh them. And then you can calculate the ratio of the seed coat to the weight of the whole seed. And if you combine that with the dry weight, there's a formula you can use that will give you an indication of the likelihood that that seed is desiccation sensitive. And if that value is above 0.5, then you know your seed's going to be desiccation sensitive and you need to look at some other method for storing it. So now that we've re-weighed our samples after drying them, we're just going to enter the data into a spreadsheet, and that's going to help us calculate the dry weight of each seed, the seed coat ratio, and the potential for desiccation sensitivity. So the first thing we're going to do is now enter in the pan weights and then the pan plus the dry weight of the sample for the embryo and then for the seed coat. Okay, so now we've entered in all our data and we've got a mean value for the total seed weight, the seed coat ratio, and the likelihood of desiccation sensitivity, which you can see here is 0.9862. That's really high. And because it's above 0.5, we know that the seed is recalcitrant, and that agrees with the data that we saw on the Kew seed information database.
And after all that, if you confirm, yes, my seeds are non-orthodox, now what? How do you know what ex situ conservation method will be most suitable?
So one of the most straightforward options for storing germplasm, say a rare plant that has recalcitrant seeds, is to germinate that seed and grow it into a plant and keep it in a pot. And then there's potential to propagate that vegetatively and maintain that. When you're talking about, potentially hundreds of species, that's quite a logistical problem. So one of the options that we're exploring here at the Australian Plant Bank is to grow the plants and then take some material from those plants and then put them into tissue culture. And then once they've established in tissue culture, we're looking at taking tissue from those shoots in tissue culture and then putting them into cryo storage. So there's quite a process to step that through that. The other option that we're looking at with the seeds themselves is to either store the whole seed or parts of the seed. So embryos from the seeds, extracting the embryos and then treating them with different chemicals and through different processes to eventually get them into cryo storage as well.
Those methods are all included in the guidelines, which luckily you can download for free.